All right, bienvenue. Welcome back to this third video in this three-part series of Introduction to R. And the whole goal of this is to democratize access to learning and using the R language. I remain Olayinka I, Arimoro, and it's been a huge honor guiding you through this process of learning R all from scratch. In the first two videos of this three-part series, we have looked at what is R and why we want to learn R, looked at some basic things about basic data types, variable assignments, and in the last video, we looked at data structures in R and some of those data structures operators like vector, matrices, data frame list, and just add a wrap up on discussing about missing values in R. If you have not looked at those two videos, please, I encourage you to go back to look at those videos, work on them, immerse them, and make sure that you are ready for this video. I would believe that this video will be relatively shorter than the first two videos because what we want to look at is R packages, installing our packages, and loading our packages, and importing files into R. Okay, so what are R packages? R packages are a collection of function and data sets developed by the community. They increase the power of R by improving on the existing base R functionality. You know, base R comes with some base functionalities like plot, like print, like SQRT that we looked at. And so people pick some of these base R functions and expand on it, all right, and provide that to the community. And so, like I said, there are over 22,000 published packages for any purpose you can think about. All right, so a package, some people even build packages for themselves, not to share with the public, just something to ease your workflow. So if you have something, a repetitive task that you do, probably you run the mean on a large data set, you can decide to write a function, and this function can do that job repeatedly, and you can decide to put that into a package. And so you just call the package and call the function from that package. And in fact, you can share it with other people. And packages are stored where? In repositories. And in R, there are three major repositories: the CRAN repository, which contains most of the packages. There is a bioconductor as well, and there is GitHub. The CRAN repository is the largest repository for R packages. It's a network of file transfer protocol, FTP, or web services maintained by the community worldwide. And so there is a group called the R Foundation that coordinates this process. And your package, I will tell you, having had experience of building one, has to pass a lot of tests. And thankfully, R makes it easy to write those tests, unit tests, for your packages, where you want to be sure that your package and function can handle edge cases. So you have to run through several checks and tests. And the process is a bit much easier these days. You have a bunch of functions in the dev tool package to do this task. All right. Bioconductor is a more topic specific repository, and is intended for open source software for bioinformatics. So a lot of the packages used for bioinformatics analysis are in Bioconductor. And with one or two, three lines of code, you can install those packages. GitHub is perhaps the most popular repository for open source soft projects. Most of the packages in CRAN actually first go to GitHub, and so you can install the developer version from GitHub. Currently, my package is on GitHub, so you can just use install underscore GitHub from I believe the dev2 package, or you can use the one from the remotes package to download that package and use it for your purpose. All right. How to install packages in R. That's our focus will be from the CRAN. That's a comprehensive R archive network. We can do that through two ways using the R Studio interface. I'll show you that, and you can just call the install.packages function. Actually, everything you do from the interface has a function behind it. So when you install a package from the RStudio interface, it still calls this install.packages function. All right. You can also load your package. So the way it works is when you install a package, that package is not yet available for the R environment. So one way you call in the package or you load the package is to use the library function. And you can also unload the package using the detach function. And of course, you might see this as you go on, that some packages, some people use require function to load the package. And the difference is that it will not throw up the error if that package is not installed, compared to when you use the library function. So conventionally, people use the library function to load in a package or to import a package. You can check the number of packages you have installed using the install.packages function. You can uninstall a package using the packages function. You can check what packages needs updates using the old.packages function. You can update all the packages using update.packages function. And all of this can also be done on the RStudio interface. Like I said, it will call any of these things you do, it will call these functions. All right. What we want to focus in today is on importing data set into R, and I'll show you how to import different data set from CSV to XLX, SX to DTA, which is a data file, to .sav, which I think is an SAS file, I believe, and SPSS file as well. Before we come to suggestion on coding style, which is where we'll round off, I would switch to my RStudio interface. I'll switch to the RStudio interface, and I believe that we are using the third. So I'm just going to open that. We are using the third file here, intro, this one script. Okay, and we'll be working with this script. It's quite a short script, and I believe we should be done in a few minutes. So the first thing we want to do is to install. All of these are just comments. I just try to beautify the comments. Anything here would not run. They are all in a comment, all right? We want to install the oldest package in R. The oldest package in R is actually the viol-plot package. I believe is used for to create a violin plot. All right. Let me clean off my console, Control L. All right. So I'm just going to do install.packages and run that. And you just need to be connected to the internet. And of course, I have that package installed, but it will still run. And just wait for it to run. It's still installing. And it shows you that the package successfully unpacked. All right, that shows you, once you see this message, it shows that the package has been installed. So when a package is being installed, you can check the package description, and you will see that this actually used to create a violin plot. Every package has a description file actually, and this package was the first package created in R. All right, and you'll see that if there was any version update, that would also be, so the latest version was 2nd of 24th of February 2025. Okay, I want to install the readr package this time. I think the readr package is to read in CSV files, but I want to show you the second method to install a package. So all you need to do is to go to packages tab on this fourth quadrant. Currently, you see a list of all the packages you have installed. All right. Of course, I've been using this for a bit and I have more packages. You'll see install update. You can update your packages, but we want to install the package. So I click on install package, and I can install from the current repository, or if I have the package archive. So when you create a package, you have the zipped file. All right, you can also load that into, and that will install the package. So every package that is being created is being submitted as a .tar.gz file. All right, but we want to install from the current repository, and we want to install the readr. The readr, and as you start typing, it gives you options. So we want to install the read R. If I want to install multiple packages, I can put a space. You can see that separate multiple with space or a comma. And I can install, for example, let me think of a package I don't have, say psych, okay, for psychometric stuff in R. So I can install these two packages and you'll see that it will use the function install.packages. And you see the C function here, meaning that I want to install multiple things. All right. And you'll see that this begins to run and it looks like the readr package is already installed, is installing the second one, which is the psych package. And that might take more time because that's a larger package actually. And so you can use, we have installed the readr package. When you install the package, I think we have to pause for a minute to allow this to finish installing. All right, and we see that that package has also been installed. All right, so when you install a package, something interesting will happen. Let's do air up read R. It says no documentation found. And the reason for that is because though we have installed this package, but we have not loaded it into the R environment. So R doesn't see this package in the environment. So it's like having a library and you have a book in the library. You have to go call out the book, all right? Bring out the book to read the book, basically. So we use the library function to first load that package in, and that tells you that that loads correctly. Warning messages, of course, are usually, it's okay, it's not a problem. Now, if you do help read R, it opens the description file, documentation about that file, and you can read about that package and the contributors. And you see the authors are Wickham, one of the very respected men in our studio, is actually the leading person with the Post-it organization. That's the new name for our studio. Created a lot of beautiful packages, the Tidyverse family of packages actually. All right, and we can continue. So we have installed the read R and the psych package and all other packages. I want you to pause for a minute and see if you can install the read XL. That's to read an XLSX file into R. So you can either use the install.packages or you use the packages tab here, install the read XL. I would not install it because I probably have it installed. So I want you to pause the video right now and try to install that package. Welcome back. I hope you were able to install the package. And once you have the package installed, you can easily just load the package using the library function. And because, remember what I said, we need to be sure. So let's do a test here quickly to show what I mean by working directory. So let me try to set my working directory to the base directory. The base directory is always the documents directory for R. Let me try to set this. So assuming the when I came to this class, my script is in the intro to R folder on my laptop where I have all of my data that I want to import. But right now, I am in the wrong directory, the documents directory. And I didn't know, I'm assuming I just opened my R freshly. Okay, when I do get working directory, that's GETWD. I see I am in the documents directory. If I go ahead to try to load this data, it will tell me an error because it says no file in the directory, no such file in this directory. You cannot open this file because I'm not in the right directory. So one of the two ways I showed you is to use a set WD and go and copy the file path and change the backslash to forward slash and things like that. Like it takes forward slash and stuff like that. That might be difficult and hard to do. Two quick ways to do that is you can come to sessions, Same way, come to choose directory, and in choose directory, you can then navigate to my intro to R folder and set that as a directory. All right, that way it will work. The other way is because I know this script is actually in this directory. This is the script is in this directory where the data set I want to work with also is domiciled in. All I need to do is to right click on this. I do this a lot because it actually makes my work easier. Sometimes on my R Studio, I can have 6 files in 6 different folders or 6 different directories, and I know their data is in their directory. So I just quickly come and right click and you set the directory for that script. So if I need to then jump to another script, I just do the same thing and I'm able to work with multiple files in my R Studio. All right. So right now I'm in this directory, and if I do get working directory right now, um, I'm going to see that I'm in the intro to R directory. And in fact, I believe that you can also look into what in this is in this directory, list the files in the directory. But I'm sure that I'm in the right directory, and I can go on to start loading in data. So the first data we want to load in here is a space separated value. So one thing you can do, because of the luxury of time, you can open each of these files, especially the like this orange separated file. And when you open this orange separated file, you'll see that this is a text file, but it is a comma separated file. If you open this one, this is a text file, but is a space separated text file. We can import all of these kind of files into R. All right, so this is a space separated file. The way you load in the .txt, that is a space separated file, is to use the read.table function. And the file name, of course, the extension is important, especially if you have multiple types of files with the same name. The extension is important, .txt, and the header equals to true. What header equals to true does is that you are trying to tell how to use the first line as the column headers. So you can do question mark read dot table. You know what that is doing by now? Read dot table. All right. And you'll see that when you scroll down, let's open up this a bit. When you scroll down and go to header, is a logical, it can be true or false, indicating whether the file contains the names of the variable at its first line. So basically, that's what we're trying to tell R, that on the first line, like in this data set, the the first line is the column's name. That's what we're trying to tell R with header equals to true. So I'm just going to run that. I'm going to run that and check the class is a data frame. You can just right click on that, double click on that and do Control Enter, and you see you can easily just print that out. Okay, the data one, and that's loaded that data. We have the txt file. You can use the view function with a capital letter V, and that opens up the data in another tab on your R Studio, and you can easily see that and quickly scroll through it if there is a troublesome column. You can use the head. Now you will see the use of head. Remember, I told you head returns the first 6 rows of the data. So if I run that, you see it returns the first 6 rows of the data. Of course, we can also have done this when you return 1 to 6 and nothing in the column. So you are saying return the first 6 rows and all the columns, basically. So that's what this will do as well. You can use the tail function to return the last 6 rows of the data. In fact, you can change it to say, okay, I want to see quickly the last 3 rows of the data, and it returns the last 3 rows of the data. By now, you should know I am running this, just pressing Control Enter. Structure, that's to check the internal structure of the data, str data. It tells you that last name is a character, sales is a numeric, country is a character, which is okay. Quarter is a character. You can change quarter to a factor quickly by, okay, first before then, let's run the summary. I think you've seen that before too. It gives you the summary of the numeric variables. For the character variable, it just tells you the length of these variables. All right. Now we can quickly change the quarter variable. That is a character. Yeah. We can quickly change that to a factor by using the as.factor function. And so I want to remember what the dollar sign is saying. I'm picking the quarter day column from data one, and I'm saving it back to the quarter column. So if I do this, and I go back to check the internal structure of that data, that will tell me that it's a factor with 4 levels. All right. If I need to do the same thing with country, for example, country's character, let's say I want to change it to a factor, but I want to maintain the previous country column. One thing I can easily do, I'm just going to be smart here, copy this, then go down here and paste it, change this to country. I want to change the country column in the data, in the data one data set. But I don't want to save it back in the same name so that I don't overwrite it. So I want to just say, call it country new, for example. Country new. Remember that R overrides whatever you have. So if I run this and I go back to check the structure of the data, control enter, you will see now that I have my country, which is still a character, the original one, and I have a country new that is now a factor with 2 levels. All right. And so this is how we build on this concept of loading data. The same way I want to load this data, but this time is a text file, but it's comma separated. And if you go back to read.table help file or documentation, you will see that there is these are some of the arguments it takes. There is the SEP. Okay, I think I missed that somewhere in front. There is a SEP. Yeah, this is it, the SEP argument. That is the separator argument. This is it. It says the field separator character value on each line is separated. So by default, it is separated by a white space. That is why when we loaded the initial data here, we didn't need to specify the SEP argument because by default, it takes a space, right? But now that we want to import a different data that is actually comma separated, like this one, it's not space separated. We need to tell R specifically that now the separator is not a space, that the separator is a comma. That's what we are saying to R here. That's the only difference. And so when we run this, all right, and let me reduce this now, and I can clean this off and check data 2. You see now that it loads that data in the tree, the age, the circumference, which is exactly what we have here on the text file. All right. And so I want you to pause the video at this point to try to check the summary of this data, check the internal structure, change the tree feature to a factor. All right. I want you to try that by yourself. So pause the video and try that yourself. Welcome back. All right. So now to perhaps one of the I'll say the most important files you might be importing is usually a CSV. There are a couple of ways to read in CSVs, and you'll see this as you go on in your learning journey. But one way to easily do that is to use the read.csv function. It takes the file name. So all of this actually takes the file name. All right. Header equals to true. And you've seen that before. And separated is comma separated because CSV files are comma separated files. And if perhaps you go and read the documentation for read.csv, okay, you will see that in this case, the separator is also space. And so by default, you needed to. So the read.csv is also part of the read.table. Okay, and you see that it takes the header true by default anyway. So if we had not put header equals to true by default, header is equals to true. For the read.csv, and the separator is comma separated, comma separated also by default. All right, so I could have easily, and now you see it in the next example, I could have easily skipped these 2 arguments and my data will still run well because a .csv, unlike read.table, that the header is false by default, in read.csv, the header is true by default, and the separator is comma separated by default. All right, so we'll run this and check the names. I think you've seen the names before. The names check the column names of the variable and the internal structure of the variable. All right, and you will see the names. And for, of course, this data set is actually a bit troublesome because, for example, marital status is an integer because the way it is numbered is 1212, meaning 1 for married and I think 2 for non-married. So when you see integers like this, because programming language is garbage in, garbage out, meaning that what you give to it is what it produces back. If you try to do some arithmetic operation on marital status, it will work correctly because currently is an integer. And that's where human reasoning and critical reasoning comes in to say, no, this is not correct. Can I change 1 to say married and 2 to non-married? So these are some of the thinking process that goes into when you get a data. So you want to probably tidy up this data to make it more clean. For example, premature status or low birth weight for low is 0 and 1 for 0 low birth weight and 1 for non-low birth weight. So, but right now it's actually saying it's integer, meaning I can do arithmetic operation on this, which is not correct. So we want to also always make sure that our data is in the proper shape and it's properly formatted. So what I want you to do now is to load in. If you look at the folder, I believe you have access to this data as well. There is a data called diabetes, all right? It's a CSV file. I want you to load it in using the read.csv function, and I want you to call it data3. I want you to call it data3. Sorry, data3, not data4, data3. And once you load it in, I want you to check the class and internal structure and return the first few rows, the first 6 rows, and do all of that. All right, those would be your exercise. I want you to pause the video right now and try that for me. All right, welcome back. So I can quickly do read.csv and just put the dataset diabetes, of course, .csv. All right, and I will run this. It works correctly because by default, header is equals to true for read.csv and SEP, the separator argument, is comma separated. I can check the class of data3, that's what I called it, and it's a data frame. I can check the internal structure of data3, and that tells you that, okay, for example, I see some also troublesome variables here like gender is 0, 1. I think 0 is males and 1 is females. So you want to probably change that. And that's where the as.factor comes in and you can give it label names. All right. The other file we want to import now is the XLSX, okay? Is the XLSX file or Excel file, all right? And of course, you can use the read Excel package to do that. You can also use the read underscore Excel. You can also use the read. I think you can use, there's also the read in R. One thing is once you start typing, R IntelliSense comes in. Read underscore X, yeah. So there is the read underscore XLSX from the read Excel package. But we want to use the read Excel function. I think this one is from, they are both from the read Excel package actually. And we have, thankfully, I believe we have loaded that package. Yes, we've loaded the package here. All right, so let's try to read in that that dataset.xlsx. So we'll run that. Of course, you can spend some time to read about the argument that this function takes. We can check the class of this, and it tells you it's a table and a data frame. A table is just a tidier version of a data frame, just a tidier version of a data frame. So you can run that, and you see that it tells you there are 14 rows and 4 columns, and the data type, last name, character, sales is a numeric, quarter, I think we've seen this before. They are both character. And one thing you can easily do is, I just wanted to say that you can do all of this from the RStudio interface as well. All you need to do is to go to File. Nobody does that, but you can do that. Go to Files and come down to Import Dataset. And you can see the different data sets you can import. You can import, for example, read R, that's the read.csv. You can import, let's say you want to import the Excel file, okay? It will tell you to browse to the location of the file. So I'm just going to browse to the location of the file. Thankfully, I'm in the right directory, so I'm just going to choose that. And it will give you the data preview as well and show you the maximum rows. And it says first rows are names, so you can see that the first rows are names. You can uncheck that, for example, and you see as you make this click and drop thing, it makes changes to the code. All right. And if I say I don't want to open the data viewer, it takes the view.c dataset away. In fact, I can give it the name I want. The name I want, let's say I want to give it my new data. All right. Let's say I give it my new data. That's the name I want to give to it. You'll see that that's the same thing that changes here. So basically, all of this is what happens at the back end when you do the click and drop approach, which is exactly the same thing we are doing with code. So that's just to tell you that all of this we are importing, we can import it as well using the RStudio interface. Let's round up here with some other data that are not conventional with R. For example, to load in a data file, which is like .dta. So there is a data called bprs.dta that we can use the read._dta function. But this function is from a package called the Avin package. Of course, with experience, I know that. And I'm not sure we have installed that package yet. So let's try our luck. Let's try to load that data. It tells you that it could not find the function read_dta. So I know where the problem is, right? That is one of two things. Either I don't have the package or I have not loaded that package. So let me first install the Avin package. Actually, I have it installed. So you can install the Avin package. Just click on install. I will not do that because I probably have it installed. Once you've installed that package, you can go back and run this, and I'll tell you it will still give you an error because we need to use the library function to bring in the Avin package. That's the point I'm trying to make here. So once I load in the Avin package, because I have it installed already in my RStudio, and I use the read_dta function, I can load in that data, and that works correctly. And I can check the first eight rows, okay? And I see the first 8 rows of that data. Okay, I can move things around, and that's why I like this 4-quadrant thing. I can move things around this way to say, okay, I want to see all of the columns that are returned. You see for here, it returns only the 7 columns and tells you there is one more variable. But when I adjusted it, I see all of these variables there. All right. And I return the first 8 rows. And of course, this data set has um, 11 columns actually. All right. So I'm just going to check again. I can do something like str, what's the name of that data? bprs data. And you see that it returns the structure of this data. And this is where actually the difference between data sets like this that are returned as a table, they are tidy versions of the tidy of a data frame. Okay, when you want to check the internal structure of data frames that are tables, there is another function you can use, but that function is from the dplyr package. I have the dplyr package, so I can easily just do library dplyr is one of the family of tidyverse packages. It's used for data manipulation. Once I load that, so instead of using the str function, I can just use the glimpse function. And I love to use tidyverse packages a lot. All right, bprs. Hopefully, I will do another video where we'll talk about that dplyr alone. It's so amazing. So I'm just going to run this. And you see this returns a more tidy version of that internal structure. And it tells you that they are all numeric. That's DBL. Like I said, unlike this one, when it's a base R, str, it just tells you num and, gives you some of the attributes, okay, that they are numeric. Okay, so we can go on to say, okay, we want to check the dimension, and this data set has 40 rows and 11 columns. Earlier here, we printed just 8 of those rows. All right. We can also load in a data file, SAV, that's a SPSS file, I believe. I believe it's SPSS file. We can also load in a the SAS file, so I can do read underscore. I think there's read underscore SAS as well. All right, if you have SAS file, it's also in the Haven package. So all of these are in the Haven package. So somebody created this package for this task of just importing data sets and for that purpose. All right, so I can load in this data set and just print out that data, and you see it tells you that their age, this is in the proper form. The gender even tells you the labels. You can then relabel that 0 is male, 1 is female, and gives you some other columns in the data set. You can also load in SAV files or this kind of data that is SPSS using the read.spss file, the read.spss function, sorry, from the foreign package. All right. So, but this one you have to put to data frame equals to true. But for me, I like using the Haven packages a lot for loading unconventional data. So I'm just going to run that, and that okay, tells me could not find this function read.spss because I've installed the foreign package. If you have not, please install it, but we've not loaded it in. So we'll load it in first and then run that, and that runs correctly. And you'll see that it says something like re-encoding from CP1252, meaning that the 2.data frame is trying to re-encode it from the SPSS file to a data frame. And so the difference is this is a data frame, but this is a table. Again, a table is a more tidier version of a data frame. I think we have had a beautiful experience and introduction to R. With this, you can start to learn, build on this foundation, learn about descriptive statistics, learn about exploratory statistics, learn about inferential statistics, and conducting tests in R, learn about linear regression, modeling in R, and you keep building and building from there. All right, so let's wrap this up with some few notes on some coding convention that I've always told students in the past. First thing, use R Studio. It's great IDE for R. It saves you a lot of time and effort. R is case sensitive. Again, be careful. Use a naming convention. It helps you and others to read your code. So you can read this article link, click on the link and go to the link and read the naming convention. For me, my own naming convention is to use the underscore. That's why if you see a lot of my script that I write, I use the underscore for my naming convention to name a variable. I use the underscore. Some people like to use the dot, but I like to use the underscore for most of my naming convention for variables. Okay. Then using coding standards, there are also coding standard. Adley Wickham has provided so much impact in this area for R and R programmers. So you can read some of these guidelines to help you. Finally, document your code. This is the most important thing when I teach students. Document your code and your function. Make sure that your code is commented. This saves you a lot of headache, even as an advanced R user. There are times when I write a script 2 years or 3 years ago, and I have to revisit it. I've forgotten what I've done in that script, but thankfully, I comment my code. So it helps me to, even though it might take a while to pick it up, but with the comment, I'm able to easily pick it up and understand what I've done compared to if I see some code and I really not it. It's really bad. They're not properly spaced. So when you read this coding standard, you will see some of these things I'm saying. When you read all of my own script, you will be able to understand that I wrote this script. When I see my own script, I know it's me that wrote it because I comment my code. I give a lot of spaces so that it's readable and it's reproducible. All right, these are some resources you can also look at. There are a lot of online resources. I want you to explore those. There are more resources here that are provided for you. Thank you so much for joining me on this 3-part journey. And I hope that it was insightful and you learned so much. Please feel free to reach out to me anywhere you watch this video, and I'm happy to contribute to your learning journey. And see you at another time. A bientôt.